Assalamualaikum warahmatullahi wabarakatuh, and good morning to all of you again. Okay, in this video we're going to look into the subtopic of 1.3 techniques of integration, and today we're going to look into what we call three different methods. Okay, the first is substitution, the second is integration by parts, and we call integral of a rational function by means decomposition into partial fraction. Okay, so techniques of integration that we're going to focus on this topic here, which is substitution, first one. Second is integration by part, and next is integration by partial fraction. So substitution method, which means that in one question here, there is a function of fx, okay, that we call the function of gx and g prime x, where we're going to come up with substitution of u, f with a we call variable of u, du, where u equal to gx. In the first one here, integral of this, integral of 2 plus ln x in bracket cube dx. Okay. So just imagine that here we get make it as one as u equal to 2 plus natural log of x. Okay. So then du equal to derivative of 2, derive 2 equal to 0, derive ln x equal to 1 over x dx. So in this case, integral of 2 plus natural log of x cube x dx. Okay, what if I come up with this one here, 2 plus natural log of x cube multiplied, so I shift this, we go a bit forward here, make it is as a 1 over x. Okay, it is 1 over x, actually here 1 over x dx. Okay, so as you can see here now, this is u, right? U equal to 2 ln x. And what about this one here now? 1 over x dx, 1 over x dx, and this is du, meaning we come up with 2, oh no, sorry. Right. So everything here, 2 plus ln x is a u, so u power of 3, and 1 over x dx is our du. Then we come out with u to the power of 4 divided by 4 plus c, and don't forget to change the u in the term of ln x, where it is a 2 plus ln x to the power of 4 divided by 4 or multiplied with 1 over 4 plus c. Okay. Next, so find integral of this one here. Okay. What about this one here now? Let u equal to 1 plus x squared. So then du equal to derivative of 1, 0, derivative of x squared, 2x dx. Okay. So integral of the question here, x 1 plus x squared to the power of 3 over 2 dx. Okay, as you can see here now, let's say if I change the position of this, shift the position between these two, x and also everything here, 1 plus x squared to the power of 3 over 2, integral of 1 plus x squared, power of 3 over 2, and then we get x dx. Okay, so we may compare now, where this is 1 plus x squared, 1 plus x squared, which is equal to u, and x dx, what we have here right now is 2x dx. So divide by 2 or du over 2 equal to n x dx. Okay, integral of this one here, which is u to the power of 3 over 2, and x dx equal to du over 2. Okay, so I bring up here equal to integral of 1 over 2 here, 1 over 2 integral of u to the power of 3 over 2 du. So then it is 1 over 2, and it now become u power of, this is 3 over 2, 3 over 2, so integral of this 3 over 2 plus 1, which is 3 over 2 plus 2 over 2, 5 over 2 divided by 5 over 2 or 2 over 5 plus c. Okay, so integral of u power of 3 over 2 is something like 3 over 2 plus 1. 1 we change in the form of fraction of 2 here, which is 2 over 2, then come out with 5 over 2. So 5 over 2 divided by 5 over 2, so bring up here, switch the position upside down, it can become 2 over 5 plus c. Okay, so 2 divided by 2, then come out with u. Don't forget to change the u in terms of this one here, 1 plus x squared to the power of 5 over 2 divided by 5 plus c. Okay, that's it. Example, the solution for this question here now. Next question, by using a suitable substitution. Okay, it mentioned here clearly, using substitution, suitable substitution, find integral of tangent theta d theta. Okay, now, class, derivative of tangent x, differentiate tangent, it gives you secant square x. But we come to integral of tangent x dx, we cannot simply come out with a result of something like this, derivative of tangent x equal to secant square. So for this one here now, we need to change this in the form of integral of tangent in the form of sine theta over cos theta d theta. Okay, so take the numerator here, sine theta, where u equal to, take the denominator here, let u equal to cos theta, and du equal to differentiate cos equal to negative sine theta d theta. Okay, so most of the time, my method or my style is, okay, for this kind of question, let's say I make this one here something like 1 over cos theta, and then sine, shift the position a little bit further front here, sine theta d theta. Okay, the reason is, what we can see clearly here, it is 1 over cos theta, where cos theta equal to u. And sine theta d theta, we can see clearly here, it is sine theta d theta. So, in this question here now, we wanted the substitution of sine theta d theta. What we have here right now is du equal to negative sine theta d theta. So we don't want this negative here, they come out. Then turn it into what we call, make a multiply with negative left and right. It gives you negative du equal to sine theta d theta. So you can see clearly here now, it's a sine theta d theta, sine theta d theta. So integral of 1 over cos theta. Okay, no. So integral of 1 over cos theta, which equal to u, and sin theta d theta equal to negative du. Okay, so equal to negative. Integral of 1 over x or 1 over u is a natural log of u. C, it is negative natural log of u equal to cos theta plus. Get it? Okay. Next, perform integration by parts. Okay. Consider the function of integral of ln x dx. Okay. I think that this example were met with this example as the first example 1 in lecture 105. The earliest of the example that is referred to the previous note of lecture 105. Okay. Okay, never mind. So what about integral of x squared ln x dx, integral of x ex dx? Okay. For this one, we cannot simply use the substitution method. Okay, we cannot simply substitute, find the u and du for this kind of question. Okay, so means that here we need to come up with a new method, as we look at here in integration by parts. So suppose u and v are differentiable function of x, then by the product rule equal to this one here. Okay, never mind. Okay, so you may just read all the notes, try to understood. You may recall us during the tutorial. Okay, never mind. Okay, I explain it here. So derivative of u and v equal to u dv plus v du. U times v prime plus u prime dot v. Okay, so integral of this left and right. Okay, integral of this respect to the v dx, and integral everything here respect to the x. So then we rearrange everything here. So okay, here now integral of u dv. So this is the formula of integration by part that we're going to use for this method of this question here. So this formula is called integration by parts. Okay, so function, using the formula integration by parts, the right choice for u and dv must be made. So function u is differentiated to get du, and function dv is integrated to get a v. L pad. Okay, this is just a hint, but okay, the formula that you can use. L stands for log, P stands for polynomial, E stands for exponential function, and T stands for trigonometric function. Okay, so find integral of x e power of x dx. Okay, look at this one here now. Integral of x e power of x dx. This we consider as a polynomial. Okay, and this is an exponential function. So which comes first in here? X, the polynomial, or exponential function. Okay, so we look at the polynomial here where u equal to an x and dv equal to ex dx. Okay, the reason that I chose ex dx as our dv, because if I choose x, okay, if I choose x here. Let's say dv equal to x dx. So when I integrate left and right here, v equal to x squared divided by 2. Meaning we double or we expand the power of x from 1 become 2. So in this part, we are going to increase or make the power of x smaller, smaller, and smaller. So x, the value of x, the polynomial here is not suitable to be chosen as a v here. Okay, in this for this example. Then du equal to, and differentiate of u, differentiate x 1 dx, and this one integrate left and right, then v equal to dx. Okay, so then uv minus integral of v du. Let's substitute one by one, where u equal to an x, v equal to e to the power of x, minus integral of v equal to e to the power of x, and du equal to dx. Okay, so we have all here u, du, dv, and also v. So what we need to do here now is just substitute all in the formula of this, and it come out with x ex minus integral of e power of x dx, again e to the power of x plus c. Okay, next. Example 2, find integral of ln x dx. Okay, class, actually that we can say this one here as an integral of 1 multiplied with ln x dx. Okay, because we need at least 2 different functions, whether log, polynomial, exponent, or trigo. Then this we classify as a polynomial, and this is log. So u equal to natural log of x, and dv equal to 1 dx. So then du equal to derivative differentiate ln x 1 over x dx, and integrate this left and right 1 dv, so v equal to nx. Okay. So then here now integral of natural log of x dx equal to uv minus integral of v du, u equal to ln x, natural log of x, and v equal to an x, minus integral of v, which is an x, and du equal to 1 over x dx. Okay, so then simplify this, x natural log of x minus, okay, this one here, integral of 1 dx. Okay, again, x natural log of x minus x plus c. Okay, so okay, if I did not use a different color between u and dv here to substitute with my explanation, I do hope that all of you understood. Where u equal to n ln x, so that's substitute here, v equal to x, here integral of v, which is x, and also du equal to 1 over x dx. So in this case, we have to substitute with one polynomial here and come up with an x, because as seen here, log comes first. Okay, differentiate ln equal to 1 over x dx. by integration by parts, fine. Okay, this one here now is between x plus 1, which is polynomial, and then cos x dx stands for trigonometric function. So let u equal to x plus 1 and dv equal to cos x dx. L pad t, polynomial come first, and then trigo the end here. So then u okay, so then du equal to 1 dx, and this one here integral left and right. So integral of 1 respect to the v equal to v here, and differentiate integral of cos sine x. Okay, so integral of x plus 1 cos x dx equal to u and v. So then sine x times x plus 1 minus integral of v sine x, and du equal to dx. So then x plus 1 multiplied with sine x minus integral of sine. Integral of sine equal to differentiate sine, it gives you cos. Integral sine negative cos plus c. So then x plus 1 sine x, negative times negative, positive, cos x plus c. Okay, find integral of x squared e power of x dx. So let u and dv. Now this one is we call the function between the polynomial and exponential function, LPET. So polynomial comes first, where then u equal to x squared and dv equal to ex dx, and du equal to 2x dx, integral great left and right, and v equal to ex. Okay, so then integral of x squared ex dx equal to u and v, x squared times ex minus integral of v ex du equal to 2x dx. Okay, so class, in this question, if this one come out with integral of ex times 2 dx, then we can simplify this as a 2 integral of ex dx equal to 2ex plus c. By the way, we cannot simply integrate this something like this one here, easily something like this, because we get an x here. Okay, so which means that we are going to come up with another of u and dv for second part only for this one. Okay, so right now, right now we are going to come up with another of u and dv. Okay, this is our reference now. Okay, that is our reference, where u and dv for the first part we refer to the question. Then we come up with another of u and dv from here. This is our reference now. So then where u equal to 2x, and dv equal to ex dx. Then du equal to 2 dx, and integrate left and right, so then v equal to ex. So nothing changed here, x squared ex minus, okay, we come out with another of integration by part. And integration by part for this one here, we are referring to this u and du. This is the first u and dv, and this is the second u and dv. So we are referring to this one here now. So u v 2x ex minus integral of v, which is ex, and du equal to 2 dx. So x squared ex minus 2x ex. Okay, negative 2 outside here. So minus 2, then integral of ex equal to ex plus c. Okay. Oh, I just put plus c outside here. Then x squared ex, negative times this, minus 2x ex, negative times negative, positive 2ex plus c. Okay. Okay, class. We got ex, and ex. So we can simplify this as an ex. Okay. X squared minus 2x plus 2 plus c. There you go. Okay. Rational function. Okay, class. Do you still remember this? Please refresh our memories about this part in semester 1, which is chapter 5 or 6? Chapter 6, right? Chapter 6, we look into the polynomials, and this one, a ratio or polynomial fx divided by gx, it can be what we call something like this: x squared minus 1 divided by x cubed plus 2x plus 5, where the degree of x from numerator is less than the degree of x from denominator. And if this happens, x cubed minus 1 divided by x squared plus 2x minus 4, where degree of x from the numerator is greater than from the x from the denominator, what we need to do to make it a rational function. Okay. Okay, so integration by using partial fraction. It's a fraction here. It's all fraction here. So if degree of fx less than gx, fx here less than gx is a proper fraction. So then check with the linear, repeated linear, or quadratic factors that cannot be factorized. Okay, it's something we call revision from our topics, chapter 6 from semester 1. Okay, right now here. So, okay, integral of 5x minus 3 divided by x squared minus 2x minus 3 dx. Let's see, what if I take this out first? Okay, so then, what about this? It is 5x minus 3 divided by, can you think of something? Okay, x and x, 3. 3 is a multiplication of pairing numbers of 1 multiplied with 3. So, 3 and 1. And this we call the difference is negative 2. So which I think that is something like negative 3 and 1 here. X times x, x squared. X times negative 3, negative 3x. 1 times x equal to x. So negative 3x plus x, negative 2x. 1 times negative 3, negative 3. So we come out with a divided by x plus 1 plus with b divided by x minus 3. Do you all still remember this? Good. Okay. Hopefully all of you still remember that. Okay, now 5x minus 3 divided by x plus 1 and x minus 3 equal to a divided by x plus 1 plus with b x minus 3. So we are going to equalize the denominator of this fraction and this fraction with the original question here. So then we come out multiply with x minus 3 and x minus 3. And same goes to this one here. Multiply with x plus 1 and x plus 1. Okay, so the denominator of this fraction and this one are already equal now with the question here. So then we can just simply look at the numerator, which is 5x minus 3 equal to a x minus 3 plus with b x plus 1. Okay, now let x equal to 3. 3 minus 3 equal to 0. So then 3 times 5 equal to 15 minus 3 equal to 12. This is already 0 here. Then 3 plus 1 equal to 4. 4b. So then b equal to 12 divided by 4, 3. And then let x equal to negative 1. So negative 1 plus 1, 0. Negative 1 minus 3. Okay, negative 1 times 5 equal to negative 5. Negative 5 minus 3, negative 8 equal to negative 1 minus 3, negative 4. B, then b equal to negative 8 divided by negative 4, 2. So it means that here 5x minus 3 divided by x squared minus 2x minus 3 equal to b. Okay, this one, let x equal to negative 1. So then negative 1 plus 1 equal to 0. Then this is supposedly a then here. Okay, sorry. This is a. So then a equal to 2 divided by x plus 1 plus with b equal to 3 divided by x minus 3. So just imagine that if we integrate this with respect to the x and integrate everything here with respect to the x. So meaning here, okay, integral of this 2 integral of 1 over x plus 1 dx plus with 3 integral of 1 over x minus 3 dx. So then 2 integral of 1 over natural log of x plus 1 divided by derivative of x plus 1, 1. Okay, plus with 3 natural log of x minus 3 and divide by derivative of x minus 3, 1. Divide by 1, nothing changed that here, plus with c. Okay, 2 ln x plus 1 plus 3 ln x minus 3 plus c. Okay, so this one, okay, it's already separate here, where x squared plus 2x plus 4 divided by x plus 2 squared, where it is an a divided by x plus with b divided by x plus 2 plus with c divided by x plus 2 squared. Okay, if this is the case of x with the x plus 2 a square here, which is a repeated linear factor. Okay, so now class again, we are going to equalize the denominator of all these three with the original question here. So it means that we come out with x plus 2 squared divided by x plus 2 squared. And this one, we need another of x plus 2 divided by x plus 2, because x plus 2 times x plus 2, x plus 2 in bracket square, and then multiply with an x here and x here. Okay, for this one here now, it already have in the bracket x plus 2 in bracket square. We just need another x. So look at all these three here now. X times x plus 2 in bracket square, x plus 2 times x plus 2, x plus 2 in bracket square, multiply with an x, and also x plus 2 square multiply with an x. Okay, so then here now, x square plus 2x plus 4 equal to a x plus 2 square plus with b x plus 2 times with an x plus with c multiplied with an x. Okay, so which method that you're comfortable with? Are we going to substitute with any value of x? Let's try with another method. Okay, let's try. With this an a expansion of this x plus 2 in bracket square, which is x squared plus 4x plus 4 plus with bx plus 2b, oh no, b times x and x, bx squared, and b times 2, 2b, and then x plus with cx. Okay, so then ax squared plus 4ax plus 4a plus bx squared plus 2bx plus cx. Okay, so then we get x squared, and x squared is between a and b. A plus b, x squared plus with, okay, coefficient of x 1, 2, and 3. We got 4a plus 2b plus cx plus with, okay, a constant of 4a only. So we compare with this one here now, x squared plus 2x plus 4. Look at this one here now, 4 constant with a constant of 4a. So then 4a equal to 4, then a equal to 1. Next, we already got the value of a here. So look at this one, a plus b, where a equal to 1. 1 plus b equal to the coefficient of x squared, a plus b equal to 1. 1 here. So then b equal to positive, bring it here become negative, so 1 minus 1 equal to 0. Okay, again, coefficient of x squared and coefficient of x squared, where 4a equal to 4, a equal to 1. 1 plus b equal to 1, then b equal to 0. And then 4a, 4 times 1 equal to 4, plus with 2b, b equal to 0, plus c equal to coefficient of x equal to 2. So then c equal to 2 minus 4 equal to negative 2. Okay. Okay, class, actually that this one here now, the original partial fraction for this is here, a divided by x, and then b divided by x plus 2, and this one here, c divided by x plus 2 in bracket square. Which means that okay, I need to copy all this again. Wait a minute. A1, B0, and C equal to negative 2. So then integral of no, this one here first. X squared plus 2x plus 4 divided by x and x plus 2 square equal to, where a equal to 1, 1 over x, plus with b equal to 0 and c equal to negative 2. So then minus 2 divided by x plus 2 squared. Okay, so we call this a fraction, and we divide into a partial fraction here. Then we get this one here, where a equal to 1, b equal to 0, and c equal to negative 2. So we integrate this everything here with respect to the x. Integrate this dx. Okay, so integral of 1 over x dx minus 2 integral of x plus 2 negative 2 dx. Okay, so integral of 1 over x, natural log of x minus 2. Okay, integral of this, x plus 2 power of negative 2 plus 1, negative 1, divided by negative 1. Okay, integral of a plus ax plus b to the power of n dx equal to ax plus b to the power of n plus 1 divided by n plus 1. And don't forget, we differentiate ax plus b, then multiply with an a here. So x plus 2 power of negative 1 divided by negative 1, and if multiply with derivative of x plus 2, 1 here, plus c. So negative times negative, positive, plus 2, and x plus 2 power of negative 1, which is 2 divided by x plus 2 power of 1 here, denominator, and then plus c. Okay, example 3. Find the solution of this. Okay, so this is a linear factor and this is a quadratic that cannot be factorized. So then x squared minus 2x minus 9 divided by 2x minus 1 multiplied with x squared plus 3. Okay, so it is an a divided by, okay, it's a linear 2x minus 1 plus with is a quadratic that cannot be factorized, so the numerator here we come up with bx plus c divided by x squared plus 3. Okay. So then now we are going to equalize the denominator of these two, the denominator with the original question here. So meaning this come out, okay, for 2x minus 1, we need to multiply with x squared plus 3, x squared plus 3 divided by x squared plus 3, and also here multiply with 2x minus 1 divided by 2x minus 1. Okay, now since that the denominator of these two are now equal with the question here, so we just look at the numerator, x squared minus 2x minus 9 equal to again, if we expand this, let's say with an a, x squared plus 3 plus with bx plus c multiplied with 2x minus 1. So class, there's only one linear factor here. The rest is x squared plus 3. So if I choose x negative 3 squared equal to 9, okay? Or x equal to square root of negative 3, or negative square root of 3 or square root of 3, you come up with 3. So 3 plus 3 equal to 6, it will give you 0. So this only the first trial can choose. Let x equal to, from 2x minus 1 equal to 0, then x equal to 1 over 2. Okay, class, for this one, you may use your calculator. Substitute x equal to half here, here, and then find out the solution on the left side. And then because 2 times half equal to 1, and 1 minus 1 equal to 0, so 0 times c, 0 times bx, everything is 0, only a left here. So you may try, and finally you get a, you will get finally a equal to negative 3. Okay, I make a short here because I said that you may just use your calculator, because I already show the step solution of the previous from example 1 and 2. So for this one, I just make it quick here. So then let x equal to 1. So you will get here where the value of b equal to 2, and let x equal to 0, where x equal to 0 here, 0 and 0 here, then you get c equal to 0. Okay, I make it short here, as I said that from example 1, example 2 of this topic of partial fraction, I already show you the step slowly one by one. So for this one, I just simply, we go give you the value of a, b and c. You may use your calculator. So now, x squared minus 2x minus 9 divided by 2x minus 1 and x squared plus 3 equal to this one here. This is original partial fraction that we formed just now. So then a equal to negative 3. Negative 3 divided by 2x minus 1. And then b equal to 2 and c equal to 0. b 2 and c 0. So then plus with 2x divided by x squared plus 3. So then integrate this with respect to the x, and also integrate this dx. Okay, now for this one here now, integral of negative 3 divided by 2x minus 1 is negative 3 natural log of 2x minus 1. And don't forget we divide by the derivative of 2x minus 1 equal to 2. So negative 3 divided by 2. Plus with, okay, x squared plus 3 fx equal to x squared plus 3. So then f prime x equal to 2x. So this is actually integral of f prime x divided by fx dx. So we come up with natural log of x squared plus 3 plus c. Okay, so then class, the conclusion, the substitution method here. Okay, and this is what we call formula for integration by parts, and this is a hint. Okay, just a guidance for you to choose which comes first. The choices of you, if it's between log and exponential, so choose a log as a u and exponential as a dv. And if it's what we call a question, we call a function between polynomial and exponential, choose the polynomial as a u and exponential as a dv. Okay, there you go. Integration by parts. Okay, linear factor, repeated linear factor, and quadratic factor that cannot be factorized, which I think that please refer to the previous note of chapter 5 or 6 for this polynomial. Okay, integration of using partial fraction. Okay, so these are all some questions for you to try, and the final answer I provide to all of you. That's all for today. Okay, thank you very much. Assalamualaikum warahmatullahi wabarakatuh, and have a nice day.